Okay, this is the first trial using the force torque transducer and different compliance for the 6 Cartesian degrees of freedom. I want to first start off by demonstrating the high compliance in the XY plane. So I'm going to set the parameters right now. We're going to set it to have an effective stiffness of 0 with some damping and have it behave like 2 masses in the XY plane. So I'm going to run the profile. Now notice how it's very responsive in strictly the XY plane. I can move anywhere in this plane and it's doing the best of its ability to stay in the plane without any twist or Z direction. Now if I move it up, nothing happens. If I twist, it doesn't have any response to the force torque, except from the shear forces. And what I can do is I can change the stiffness and the damping to make it feel more viscous. But for now, this is all we're going to do. Okay, so that is a demonstration of compliance in the XY plane. Now what I'm going to show is compliance in the up direction. So we're going to set the masses really high and change the effective mass in the Z direction to something a little more, a little lighter. Okay, so we're going to set the spring constant higher, and this should show a mass in the up direction. Now notice now it's not responsive to any XY plane moving. That's due to the low back drivability of the platform. But it is responding like a mass spring damper in the Z direction now. What I can do is I can change the effective mass to something a little lighter. Now notice how it's more responsive. This also in turn changes the natural frequency of the response to a force input. So I'm going to change the mass spring ratio. Okay. I'm going to let it settle. The final thing I want to show is a Z twist response. So again, I'm going to set the spring constants higher, but I'm going to set the mass, the moment of inertia. So now notice we have a response that's really almost underdamped. So what I'm going to do to mitigate that is increase the damping. I'm actually going to add a little more mass. Hopefully that will change the response, maybe change the stiffness a little lower. Go ahead and twist this. These are just trial and error parameters. And notice now I can't move. It's not very responsive to shear forcing, and it's not responsive at all to force in the Z direction, just strictly that Z twist. Now I can add back that response in the Z direction if I wanted to. So now we have kind of a coupled response. We have our Z, but we also have our Z twist. But we don't have any gamma twist or about the X or Y axis, just the Z and the Z twist. All right, cool. Gonna record. And what we got here, it's kind of hard to see. This last portion here was our Z twist I was showing. I'm superimposing the plot, so this is degree twists. We can isolate that, but the video speaks for itself. And this concludes the compliance demonstration for 3 of the 6 possible degrees of freedom. Actually 4 if you include the Euler angle about the Z direction. Alright, great.